Hi guys, today's notes are on the trig functions, our 6 trig functions given a trig function. So basically now what we're going to do is instead of me giving you like a point or an ordered pair, I'm going to give you a trig function and the quadrant it's in, and then using that information you should be able to sketch a picture or like a picture and find the remaining 5 trig functions. Before we do this, let's do a quick review. Let's see. I'll do this over here. Remember that if we have a point, x, y, and we always go up and down to our x-axis for our reference angle, then we know that sine of theta is y over r being the radius, y is your y length, and x is your x length. Then cosine theta is x over r, right? So adjacent over hypotenuse, and tangent theta is y over x. The reciprocal functions, cosecant, let's try that again. Sine starts with s, so this must be cosecant theta equals to r over y. Secant theta must be r over x, and cotangent theta equals to x over y. So reciprocals of these. Okay. So if we know these 6 trig functions, we know a little bit more about this point in quadrant 2. Let's do a quick sketch. Now, not to scale, I know that the point is going to be somewhere over here. Okay. That means my triangle is going to be this one. Here's my reference angle down to the x-axis. It's always a 90 degree. And then sine is y over r. So that means y must equal to 1, and r equals to 4. Well, can we find x then? Right, so now we can use a Pythagorean theorem. Do 1 squared plus x squared. Now be careful, the 4 is your radius, so that has to be on its own on the other side. Okay, so that's something you have to be careful of. Sometimes I might give you x and y, right? So you have to make sure that your Pythagorean theorem is set up correctly according to the picture that you have drawn. Notice this is not to scale, like this is not 1, right? But that's okay. So now we have 1 plus x squared equals to 16. Subtract 1 on both sides. And square root both sides. Up until now, we've been using positive lengths, right, for x, or y, or r. The problem now being that this is going in the negative direction, right? So in quadrant 2, because I've told you it's in quadrant 2, my x needs to be negative. So, let's see, how should I write this? This is a negative number. And we know that when we square root both sides in Algebra 2, we really emphasize having a plus or minus, right? And so you need to now identify which one is it. Well, we know now that x is going to be negative square root 15. Okay? 4 is equal to r, and 1 is equal to y. So now using these 3 values, I can write my 6 trig functions. So let's see. I've got sine theta is what I started with, 1 over 4. Cosine theta is, let's write it. X over r, which is negative root 15 over 4. And tangent theta is y over x. So my y value is 1. My x value is negative root 15. If we multiply top and bottom by root 15, that'll give you 1 root 15 over 15. The negative we have on the bottom, but now moving forward, we want to move the negative to the top, okay, just to be consistent. It's just more mathematically correct. Here, I'm going to box this one since it's already given. Okay, so now we can do cosecant theta, which is just 4, right? It's the inverse. So notice here I'm not bothering with ry, rx, or x over y. Now I'm just looking at the 3 that I already have. Secant is going to require a little bit more work since I'm taking the reciprocal, 4 over negative root 15 multiplied by root 15. So it'll be 4 root 15 over 15, and instead of the negative on the bottom, I'll move it to the top. Cotangent theta. I don't want to take my final answer and do cotangent theta. I want to look at this one right here, because that's so much easier to take the reciprocal of. I know that it'll just be negative root 15. It's a lot less work. If you multiply this one after you take the reciprocal, everything will cancel out and you'll still get the same thing. So the only thing you have to be really careful of here is you have to decide if x, y, or r are negative or positive. So let's keep going. We know that tangent is y over x. Well, there is no x, so we know it's going to be over 1. We're going to do quadrant 3. 1 is always like in your positive direction, right? We start at 0 degrees. 2 is the next quadrant when you go positive, right? So here's 1, here's 2. Oh, sorry, I don't need 2. I need 2 in this one. And then I need 3 for this one. 1, 2, 3. Quadrant 3. Okay, so I know my point's somewhere in here. Doesn't matter if it's to scale. Drawing it to my reference angle. Y is 8. And x is negative 1. Notice that's very not to scale. Sorry, it's 1. I threw a negative automatically because in the left direction, 1 is negative and 8 is negative. But it shows up as positive here because negative divided by negative would be a positive. So I gave you the simplified answer here, but you actually have to use these numbers over here. So this is your x, and this is your y. Once we have those, we can find our Pythagorean theorem, x squared, negative 1 squared. And these are not the hypotenuse, right? So y squared is negative 8 squared equals to r squared. That's what we're looking for. So this is negative times a negative is a positive. It's always going to be positive, guys. R equals to square root of 65. R is a radius of a circle, so this is always going to be positive. So there are your 3 values. And now I can do sine, cosine, tangent. So sine is y over r. Y is negative 8. R is root 65. That'll be negative 8 root 65 over 65. I don't think 8 and 65 can be simplified, so we're done. Cosine theta, x over r. Same thing, but with negative 1 now. Okay, and tangent. Theta I was already given, so I know that's 8. I just like to write it because it helps me over here. So here's cosecant theta. I'm not going to look here, I'm going to look at this one, right? Because that'll help me here. So now if I take the reciprocal, root 65 goes on top, and 8 goes on the bottom. I am going to put the negative on top though. We're going to take again, go all the way back, because this is way more complex. So I'm going to take, I think root 65 over 1 is just root 65, and there's a negative. Cotangent is going to just be 1 over 8. Okay, so this seems fairly straightforward, right? You just have to be careful. Now, the biggest mistake that people will make is their positives and negatives. So let's do one more, just to make sure we've got this. We're in quadrant 2. Here's your theta, here's your triangle. Cosine is x over r, but the negative is in the middle. Now this is where it's really helpful to just put the numbers on here first, 2, 5, and we recognize that this is in the negative direction to get to this point. So the negative must go with the 2. Okay. Also, we know that r is always positive, right? So that is another signal that that's what it is. But most importantly, looking at the picture, we know the 2 is negative. So this is x equals negative 2, r equals 5, and we can solve for y. We get, let's see, negative 2 squared plus y squared equals to 5 squared. So 4 plus y squared equals to 25. Y squared equals to 21, and y equals to root 21. And it is positive because it's going up. Okay. So at this point, you write your 6 trig functions. Pause your video here so that I can write out my answers, and then you can check them just to make sure you've got the simplifying radicals. Let me know. Okay, at this point we have u tries. Before we get going, I just want to sketch this first one out for you just so that you can be sure that your quadrants are in the right place. Ready? Quadrant 4. That is not quadrant 4. Apologies. Okay. Cotangent, let's go check. Oh, sorry. That's x over y. So I have x over y, which is 1. So if x is 5 and y is 1, notice that this 5 is actually positive and this 1 is negative, right? Because it could be positive 5 over negative 1, and if we simplify it, then it's negative 5. So that should be it. I would definitely try practicing these problems and see if you can get the same thing as your classmates. Let me know if you have any questions.